The fading giant, Betelgeuse, and the James Webb revelation. The massive red star, classified as a supergiant in the constellation Orion, is nearing the end of its stellar life. But in recent years, something strange began to happen. An event that took even seasoned astronomers by surprise and filled the scientific community with intrigue and questions. Betelgeuse began to lose brightness, and not just subtly but drastically, in a manner so unexpected that it sent shock waves through observatories worldwide. A few years ago, astronomers noticed something surprising and unprecedented. Betelgeuse, which had shone so reliably in the night sky for centuries, began to fade and fast. For a star that blazes so brightly, this sudden and dramatic dimming generated a wave of theories, speculations, and assumptions. Was it dying? Were we about to witness a supernova in our own galaxy, one that would be visible even to the naked eye? Expectations reached an all-time high as scientists scrambled to understand the phenomenon. The variation in brightness of Betelgeuse was so drastic that many believed the end was near. A supernova visible from Earth would be an unprecedented event in modern history. A celestial explosion capable of lighting up the night like a second sun. The mere thought of witnessing such an event filled both astronomers and the public with a mix of awe and anticipation. That year was full of uncertainty and excitement. As telescopes across the globe gathered data, theories about the star's impending explosion became increasingly popular. News outlets and scientific journals alike reported that this could be the cosmic event of the century. But despite the fluctuating brightness and intense speculation, the explosion never came. Then came the James Webb Space Telescope, a marvel of human engineering and ingenuity designed to see further and deeper than humanity had ever imagined. With its launch, the world of astronomy gained an unprecedented tool capable of capturing cosmic details with astonishing clarity, revealing truths that were once only the stuff of theoretical models. Equipped with a golden mirror more than 6 meters wide, the James Webb Telescope was built not only to peer into the far reaches of the universe, exploring galaxies billions of light-years away, but also to unravel the mysteries within our own galactic neighborhood. Naturally, Betelgeuse became a prime target for the mission given its unusual behavior and proximity. Could James Webb give us a clue as to what was really happening at the heart of this stellar giant? Was it possible that we were witnessing a phenomenon that defied the known laws of astrophysics? Something that might challenge everything we understand about the death of massive stars. The wait for a concrete answer was almost unbearable for the scientific community. And then finally, the image arrived. A breathtaking high-resolution portrait of Betelgeuse captured by the James Webb Space Telescope. It was not just a photograph, but a window into the star's inner workings. More than just a beautiful image, it offered a brand new perspective on this red supergiant, one that challenged previous assumptions. However, what scientists saw was not what they expected. Through the James Webb's powerful infrared eye, Betelgeuse appeared not just massive, but dynamic, alive with violent activity that belied the idea of a star quietly nearing its end. The telescope revealed a strange, almost mosaic-like pattern on the star's surface. Something that until now could only be guessed at through indirect observations. Scientists noticed that far from being a dying dull star, Betelgeuse exhibited hot spots and large bright regions, clear evidence of full and ferocious activity. These images showed that Betelgeuse is surrounded by a vast cloud of gas and dust, a shroud it has ejected from itself in waves of violent eruptions. Violent explosions were occurring on its surface, giving it a turbulent and ever-changing appearance. This ongoing activity could be responsible for the variation in its brightness, explaining the sudden dimming that sparked global speculation. With the James Webb image, the surface of Betelgeuse emerged as a kind of cosmic battlefield. Huge regions of the star brighten and dim in a matter of weeks, an unusual behavior for a star of its size and stage of life. These explosions, known as stellar mass ejections, can hurl material in all directions, creating spectacular clouds of gas that envelop the star like a veil. This unpredictable and extreme behavior in Betelgeuse sparked several new theories among scientists. Some researchers believe it is a sign that the star is entering its final evolutionary phase, rapidly shedding mass as it prepares for a dramatic supernova. Others think it may actually be stabilizing, undergoing complex cycles of magnetic and convective activity that we are only now beginning to detect with modern instruments. One thing is certain: Betelgeuse is behaving in a way we have never before witnessed in a star of its type. What we are seeing defies conventional knowledge of stellar life cycles, forcing us to reconsider our long-held assumptions about how massive stars evolve and die. While astrophysicists know the general process by which massive stars die, the data from Betelgeuse suggests we may have underestimated the complexity of this late stage. The image captured by the James Webb Space Telescope does more than reveal the details of a dying star. It forces us to reflect on cosmic timescales and our own fleeting presence in the universe. If Betelgeuse were to explode into a supernova, the event would be visible from Earth for weeks or even months. It would light up the night sky like a second sun, spectacular or inspiring and yet completely safe for us here on Earth due to the star's distance of roughly 642 light-years. Although we are not in danger, the implications for science would be monumental. Such an explosion would offer astronomers a rare opportunity to study a supernova in real time. For the scientific community, witnessing a Betelgeuse supernova would be like attending the universe's most dramatic physics lecture, an event where nature itself demonstrates its most powerful forces. We could learn how these cataclysmic events distribute essential elements like iron, oxygen, and carbon across the galaxy. These elements eventually form planets and, as we now understand, even the basic ingredients for life itself. Indeed, the James Webb image not only illuminates the death throes of a massive star, but also carries crucial implications for the future of space exploration and science. Observing a phenomenon of this magnitude could reveal secrets about how planetary systems form and how life-essential materials spread through the cosmos. In fact, many of the elements in our own solar system were born in stellar explosions like the one Betelgeuse may be preparing to unleash. Every atom of oxygen in your lungs, every atom of carbon in your body, these were forged in the core of a giant star. In a way, watching the end of Betelgeuse is like watching the end of life itself and the beginning of another. As astronomers, it is a profound privilege to study such cosmic events. They remind us that we are connected to the universe in ways we are only beginning to understand. Every time a dying star like Betelgeuse releases its final burst of energy, it seeds the galaxy with the raw materials for new stars, new planets, and perhaps new forms of life. The James Webb Space Telescope has not only given us an unprecedented view of Betelgeuse, it has opened the door to a new era of astronomy. And its mission is just beginning. From distant galaxies to potentially habitable planets, the James Webb is designed to look farther and deeper than humanity has ever reached. What it has captured so far is just the beginning of a revolution in astronomy. The image of Betelgeuse is one of many wonders that Webb could reveal in the coming years. From star formation to the search for life, each new observation represents an opportunity to unlock the universe's deepest secrets. The James Webb is not just a telescope. It is a time machine, a portal to both the past and the future of the cosmos. Every image and every data point collected by this revolutionary observatory may rewrite what we thought we knew about the universe. And perhaps one day answer the question that has intrigued us since the dawn of time. Are we alone? What do you think of this stunning new image of Betelgeuse captured by the James Webb Space Telescope? Do you believe we are about to witness the spectacle of a real supernova in our skies? Tell us in the comments what you think about this discovery. And if you want to keep up to date with the wonders that the James Webb continues to uncover, subscribe, follow, and stay curious. The James Webb Space Telescope's revelations about Betelgeuse mark not just a moment in scientific achievement, but a turning point in how we perceive the universe's most powerful stellar phenomena. For centuries, Betelgeuse has held a peculiar status in the night sky. Easily visible with a naked eye, shimmering with a faint reddish hue in Orion's shoulder, it has inspired myths, legends, and countless nights of stargazing. To the casual observer, it was just another star, a red jewel glimmering in winter skies. But to astronomers, Betelgeuse has always been a ticking clock, a cosmic countdown to one of nature's most dramatic events, a supernova. But why exactly is Betelgeuse's fate so important? The answer lies in the mechanics of massive stars, which live fast and die young compared to smaller stars like our Sun. As a red supergiant, Betelgeuse is nearing the end of its life cycle. It has already exhausted the hydrogen fuel in its core.